Thank you. All right, well, good morning, everyone. It's still morning over here on the West Coast. My name is Jim Walth. I'm a senior biologist for the California Department of Transportation, or otherwise known as Caltrans. I've been asked to speak on Caltrans' method of estimating enrolled acres using a GIS model. I'm going to present the general rationale for the model and walk through the variables and the outputs. And feel free to ask questions if they occur to you. All right. So the model Caltrans adapted was based on a 2018 senior project undertaken by 3 CalPoly San Luis Obispo students. Their project utilized model parameters based on the narrow-leaved milkweed, or Asclepias fascicularis. The narrow-leaf milkweed was the most widespread species of milkweed in the West, and its habitat needs generally overlapped most of the other species also found in the West. So it made an ideal umbrella species to base a model on. So their study was limited to 1 county and utilized fairly coarse data sets. So my colleagues and I adapted their model to cover our entire right-of-way and to, in general, improve the resolution of the output. So this was a good starting point. With a lot of work, we were able to adapt it. We mostly adhered to the original model's parameters used in their study with some additions in terms of filtering. So the rationale for using a model approach, as I'm sure others will appreciate, is that our right-of-way is just too vast to survey in a on-the-ground method. Caltrans' right-of-way consists of about 425,000 acres and almost 16,000 linear miles of highway in California. So there's no physical way we could possibly survey or even sample such a large section to come up with a reasonable estimate of enrolled acres. We also needed to determine, hotspots of high-quality habitat, areas where enrollment would be most beneficial within our right-of-way, and to help us inform our conservation efforts and help us in our district outreach. So I'm not sure how other DOTs are arranged, but Caltrans, or California Department of Transportation, is divided up into 12 semi-autonomous districts. And each district is making their own decision as far as enrolled acres and participation. So it was essential for us to come up with a reasonable idea or estimate of what each district's habitat looks like and needs would be. So it's kind of a nice challenge. So let's jump right in. The model variables on the surface are very straightforward and fairly simple. There's really 5 main variables. And again, these are based on Asclepias fascicularis. The model variables were precipitation, elevation, slope, soils, and aspect, and really focused on the optimal growing requirements for that species. So I'll briefly go through each of these inputs. So the first one was, of course, precipitation. The model identified 9 inches to 35 inches annually as the most optimal level, optimal rainfall for the narrowleaf milkweed. I should say, for the most part, the low, when it's indicated low, it would equate to a value of 0 in the model, and a high value would be a value of 1. Of course, throughout the model, there is weighting applied to these values. Dependent on the relative importance of the different ranges. So in general, it's 0s and 1s, but in some cases, we'll double the value depending on how strongly that variable affects the growth of the species. But for simplicity's sake, I'm going to stick to the low, moderate, and high value system throughout the rest of this talk. And we'll go through these next ones pretty quick. Elevation, we used a fairly high resolution DEM. It was, in some cases, a 3-meter DEM to estimate the elevation. But really, the high value for the optimal range is 164 feet to 7,217 feet above mean sea level. In this case, moderate received a value of 1, high got a value of 2, and low was a value of 0. So we're kind of excluding their limit to this range. All right, elevation. So now we start working on slope. So the optimal range for the slope for narrow-leaf milkweed was any slope under 20 degrees, as long as it was not a north-facing slope. So we used an aspect input variable as well to determine the which orientation, the aspect of the species of the slope. So in this case, again, high would be had the higher value, and in general these are zeros for anything low in this case. So this is slowly building the model inputs. Serpentine soils was also included. So in California, our state rock, the serpentine rock, produces a very toxic soil. So this soil is the only soil type that narrowleaf milkweed will not grow in. So the model excludes serpentine soil. So again, this is very dependent on the species of milkweed. I'm not even sure if serpentine soils occur much outside of the West. All right, aspect was also included, as I mentioned, and essentially aspects were the high suitability areas for narrowleaf milkweed are really any aspect other than north facing. North facing would have would just be too shaded. So the model weights the other aspects higher. All right. So the model combines those variables in a fairly complex model formula. But beyond that, we also wanted to limit or filter the model output for a couple reasons. One is we wanted to limit the model to our right-of-way. So we don't want, because we're only focused on what we own. Now, that seems simple on the surface, but like a lot of DOTs and a lot of other entities out there, we did not really have a model or any kind of feature layer for our right-of-way. So we had to create a separate model to create an approximation of our right-of-way. And I'd be happy to talk to anyone about how we did that if they're interested offline. It's actually very interesting. We also wanted to exclude all paved surfaces. So Caltrans chose to exclude the roadways and other paved surfaces since no milkweed would be present on those surfaces. And really, this is probably the single most important limiting variable we used, because it really removed a vast amount of our right-of-way that really obviously would not support milkweed. And that really brought our enrollment needs down to a more reasonable level. We also excluded heavily urbanized areas, again, for the same reason. We removed creeks and other water bodies as well. So the footprints of those creeks or water bodies were also removed because presumably those would be water or flow and no growth of milkweed. And we also removed overwintering areas, a 5-mile buffer around each overwintering area from the model, and we are treating that in a separate model, and we'll be including those estimates for enrolled acres separately, just because we're treating them differently. They have different conservation measures, and that was really a decision that we made after the CCAA was updated to include specific measures for overwintering areas. So you'll see some maps and photos here that won't, they won't be showing any overwintering areas, but we are including those in a different model. So this is, so all that sounded fairly simple. In practice, this is the actual layout of the model that we ended up using. You can see it's fairly complicated. There are a lot of weighting variables within. There are a lot of calculations. The entire model was run ultimately in a Python script separate from the model builder due to resource needs. The model uses very large data sets and many individual calculations, and we had to really run one district at a time. It took about an hour per district to run. This model required ArcGIS either Pro, I believe it was run in Pro, and it utilized the Spatial Analyst extension for those that are interested. Some of the slope and aspect calculations really required that. So the outputs, these are the exciting part finally. So we produced two basic types of outputs. So the first was the a polygon feature data set with model values reclassified to a high, moderate, or low suitability. So red are areas of high suitability, yellow, moderate, green, low. This is for simplicity's sake. The actual model, of course, has a index range of 0 to 16. So it's much more fine grading in the actual model. But for simplicity's sake, we reclassified those. And blank areas are considered 0 suitability. So you'll see there's some gaps in the polygons there. Those are areas of no suitability. We then did something kind of unique. We took those polygon values and we essentially averaged them along a linear referencing system to produce a linear or planarized version of the model. And you can see that on the right. Now, the reason why we did this for two reasons. One, our maintenance divisions really think about resources along our highways in terms of linear features. They think about sections of highway. So this made more sense to our maintenance staff and to our partners. The other reason was that when presented on in a cartographic, they really present better cartographically in a linear file rather than a polygon. And you'll see basically because of the scale. When you zoom out to say 12,000 to 1 zoom, you can't even see the polygons because they're so small relative to the rest of the area. But you can see the polygons very well. So this is more of a cartographic reason and a communication reason to create this. But we have both. So with this model output, we are going to use that to estimate our enrolled acres. It will also help us to determine our avoidance and minimization measure overlaps with plant and critical habitat. And it'll help us to estimate the adopted acres. And we'll be doing this by district, by route. So these are some of the maps we produced, and you can see the linear version of the model is much easier to represent on a map. You can see that you can get a really quick idea of District 2 and District 5. District 2 is up north, District 5 is the Central Coast, just north of, between Santa Cruz and Santa Barbara. And you can get an idea of where our hotspots are based on these mappings. So the red and yellow are fairly high value. So it's a very quick reference. For more detailed information, we of course produced summary tables for the different districts and collectively. And of course, these files we also provided to the districts as feature layers with full attribute tables and full model variables, so they can actually do the summations the way they want. So we have very precise estimates of the suitability areas. And we divided them up into high, moderate, and low suitability areas. And that's really to help inform the districts of potential areas to focus their conservation efforts, likely focus more on high suitability and moderate suitability over low. We also, in this one, I highlighted the three routes within, this is District 5, that had the highest amount of acreage and linear miles. So in District 5, Central Coast, looks like Highway 46, 101, and 166 had the greatest amount of suitable habitat. So this is information that lets us, we're going to use as a tool to estimate our enrollment. Now, keep in mind, again, these districts are all semi-autonomous, right? So they're going to look at these numbers, they're going to look at the maps, they're going to look at the tables. They're going to adjust those based on their specific needs. So they may add to the enrolled acre estimate, they may subtract, they may use the tool to estimate their adopted acres or not. But it's really produced as a tool, and it lets us finally get out some real numbers. So for California, our grand totals, and I wish I would have put a slide in for that, we came up with an estimate of 62,000 acres of suitable habitat, high, medium, moderate, or low, out of the 425,000 acres. So it gave us a real number we could actually work with. And again, there was no way we could come up with that number other than just a gross estimate based on average width of right-of-way, and some average amount of concrete. So this really gave us some science and some real data that we can show the public. And speaking of showing the public, because we are a transparent agency, this model is available online at the website below. We have a environmental GIS library that is used for mostly within the agency, but also it's a public site, I believe. So you can explore this map if needed. Yeah, so that basically concludes how we are intending to estimate our enrolled acres and our adopted calculations, and how we're going to communicate that to our partners and to our districts. Are there any questions? Looks like I got a question. Let's see. How are these acres? So I got a question. How are these acreages calculated, assuming right-of-way width per road or known right-of-way? Well, the acreages are calculated directly from the polygon layers, and I can flash back. So if you look at the polygon layers in these features, they're actually, each of those polygon layers, there's of course an attribute table that has the acreage estimate within that, and it's just a simple tally based on area.
This is Iris. Maybe one just point of clarification. Jim, again, very helpful. I think. Thank you for presenting this whole modeled approach, and I think certainly shows a really strategic way of thinking about your enrolled lands. Obviously we have other partners who, for the sake of initial enrollment, are essentially enrolling everything. So that's another approach to take. But as you have data available, I think like this model shows, to really kind of zero in on what are those areas of suitable habitat and where should you be focusing your conservation measures. I think examples like this can be really valuable.
Thank you. Looks like we got a few more questions. Do we have time for a few more?
Yeah, go ahead.
So there's a question here. What is planned for these acres? Are you implementing selective herbicide treatment or to control invasives and release natives? So what's planned for these acres? So the acreages shown in this model are provided to the district as a tool for those districts to decide how to best implement conservation measures. So again, we're semi-autonomous districts. Each district is going to decide that for themselves, but this gives them at least a starting point for where to focus those efforts. So it may be herbicide treatment, alterations to their veg control plans, mowing, seasonal mowing restrictions, that kind of thing. But this will at least tell them where they should focus those areas, those activities on. So again, this is a tool. Our headquarters, which is where I'm part of, we don't decide for the districts what is enrolled and what will be considered adopted acres, but they are responsible for 8% of whatever enrolled acres they choose to enroll. And I got a question with, how has your communication with the divisions gone? Are you getting so buy-in with maintenance managers? That is, and I'm sure everyone can appreciate this, probably the biggest challenge. Maintenance managers are often very stretched thin in terms of resources, especially time and funding resources, and they're really unwilling to put a lot of those resources forward. It's a challenge. We are really emphasizing what those divisions are going to get out of enrollment. And really, that is the biggest selling point. And that has really helped quite a bit in our communication, is just emphasizing that. And emphasizing also that, the whole district as a whole will be achieving the adopted acres goal, not just putting on the shoulders of maintenance. Another question, do the districts have their own biologists, ecologists, and make those manage? Yes, our districts do. Our districts have full environmental divisions with biologists and full environmental staff. They are equipped to make these decisions and contribute. We do very little consultant environmental work. We do most of it in-house. Well, no questions about the model. It must have been either really, really clear or really confusing. Let's see. So I wanted to put up this just in case anyone has any questions offline. Feel free to call me or email me anytime, and I will be happy to talk about the model and the resources. And I do want to give thanks to our Division of Environmental Analysis GIS specialist, Anthony Barnes, who was instrumental in facilitating this model and really doing a lot of the hard work on it.
Hey, Jim, this is Tim Lohner, AEP. Really good presentation. I don't have a question about the model either, but maybe this is more for Iris. Would this kind of analysis meet the requirements of the CCAA in terms of identifying, enrolled versus adopted acres?
Yeah, so I think kind of to the point that I was making earlier, again, we've tried to build a lot of flexibility into the CCAA to allow organizations that do have really detailed data, like what Jim has presented, to be able to utilize that. But then fully recognizing, I've talked to a number of you who have come to me sheepishly saying, we don't have we don't have good GIS data, and I think that's true kind of across the board with a lot of DOTs and utilities. So I think recognizing that we're all kind of coming at this from different points potentially, we've tried to be flexible within the CCAA. Also recognizing that data quality will probably improve, over time with enrollment in the agreement. We may be able to adjust some of those enrolled acres, up or down, potentially down as data improves And so again, I think the intention is to keep it flexible, so organizations can use the best data they have available.
All right, thanks.
Well, any other questions? Well, I really appreciate everyone giving me the time to share our work. Thank you.